Okay, so for week 9 video, I did mine on Boulder, Colorado. I love Colorado, so I thought this would be a fun presentation to do it on. Okay, so this is a satellite picture of Boulder, Colorado. Here's the city. On this side, the east side, it is very flat, not really any elevation or anything. And then on the west side, on this side over here, we have mountains, it's rocky, high elevation, all that fun stuff. The specific place I will be talking about today is the Flatirons, which is this area right here. Okay, so just some quick research that I did. The east side, which I just talked about, is flat. The west side has mountains, and the cause of these mountains is just millions of years of just the landscape changing. Yeah, sorry. Okay, so these rocks, they are sedimentary rocks, and as we know, those are formed by broken fragments of other rocks. And the Flatirons, which is in the west, the Flatirons, they consist of giant slabs of red sandstone, and the age of that is about 290 to 296 million years old, right around that time area. And as mountains are worn down, coarse sand and gravel get deposited everywhere, and that eventually hardens into rock. So this is a cross-section map of Boulder, Colorado. We have our flat plains and then our mountains. It's just this is the Boulder area. And then this is the geological map, and we can kind of see, this is the flatter area, and then we can see the mountains. The colors definitely enhance that for sure. So just a couple more research topics. So how are rock layers of different ages distributed? Well, as we already know, and we already talked about this week, the oldest rock layer, it starts at the bottom and the youngest is at the top, and that just, I guess, yeah. So we already know that. So how are layers oriented in space? So specifically for Boulder, between dip and I forgot the other one, but this one, this is dip specifically because it is as we can see. Sorry. Oh, okay. It is angled. It's not just flat. We can see these angles. And actually, this right here is a hanging wall block, and then this is a foot wall block. We can see that pattern happening here and here and here. So we can see that all throughout the mountain. So yeah. So how are rock layers deformed? So as the mountains are uplifted, streams they carry debris down to the plains, and then hot magma it invades the older rocks in the mountains, and then those forces cause the rocks to deform greatly. And as I just said, as I just talked about the foot wall block and the hanging wall block in these areas right here, those are faults. Between faults and folds, this specific area in Boulder, Colorado, these are faults. So that's all I have. Thank you.